Hello everyone, thank you for joining us today and let's have a great day together. Please join me in welcoming our first speaker, Ionut. Hello. And
Hello. Hi.
his topic will be techniques for a faster JVM startup. The stage is yours, Ionut.
Thank you so much. Welcome, everybody. Let's quickly make the full screen. Good. So basically, the topic for today is some techniques for improving the JVM startup, especially the cold startup. The agenda for today is a bit packed in the sense that I will briefly explain to you when this JVM startup matters, for what kind of applications, right? Because you might not be particularly interested into this topic on a general purpose level. Then I will actually touch or present to you three techniques how to improve this startup performance. A few things about me. I'm software architect for Raiffeisen Bank International in Wien, in Austria. Besides this, I also do trainings. I'm security champion. I write articles, and of course, I talk to conferences, as you can see. And if you are particularly interested in one of these topics, for example, software architecture, performance, also from an architectural standpoint, how to design high performance applications. Also, because I worked in banking industry more than 1 decade, I got a lot of knowledge into the security. There is a training on this. So in a nutshell, if you have this need in your company, get in touch with my catalog. And mainly that's it about myself. Let's quickly start and see when this JVM startup matters, right? For which kind of applications? Usually, this matter in particular when you have short-lived applications. For example, you have application which does one thing and stops. And basically, this is the case for what we call today serverless applications, in particular function as a service applications, because a lot of people is basically using cloud, and in cloud, there are some use cases where you don't want your microservice to be up and running continuously. If you have, for example, very irregular processes scheduled once in few days, it's very nice to create a function as a service, because at the end you save the costs. And you might notice, for example, if you have tens or even hundreds of such applications deployed in cloud, the bill could be impressively high. Other benefits, of course, you get quick feedback loops during development cycles, because if your application starts quicker, you can potentially get fast feedback about your previous changes, so you can react in a faster way. All in all, this is the category of applications where the startup time matters. I cannot pretend, for example, it really matters in case of microservices where you have a long-running application. Yeah, in such a case, not in particular, but in this kind of function as a service, mobile applications or short-lived applications, it really makes sense to improve it. And now let's see what are the techniques to improve this. There are quite a lot. Of course, I cannot talk about each of them. I will focus today on the top three. Of course, there are others, like for example, Alibaba Dragon Whale, JWarm. They created very nice approach to warm up your JVM. If you pay the license for Azure Zing, the Ready Now technology is there. You can also potentially improve your startup time for your application by playing with JLink, removing some modules. And there is a recent initiative. It's called Project Layden. That targets basically the startup application time. All in all, as mentioned, there are a lot. I'll focus today on the first three. In a nutshell, what I'm doing, I'll quickly present how they work, how you can trigger in your application, and I will measure the timings at the end. Okay, so first let's start with the app dynamic CDS in HotSpot, because basically HotSpot is actually the JVM which is the most used across our production systems. And of course, it makes sense to actually take a look and see what's in there. I will start briefly explaining a bit from a historical perspective, because it's always important to understand this in order to better judge for yourself what is bad, what is good and what fits. Basically, this what is class data sharing. You know, when you start your application, you start with a class path, or if you don't explicitly set it, there is a default class path, and all the dependencies in terms of classes, for example, they are loaded from jars. This in the format of bytecode, they are parsed, they are checked if they correspond to the specs, there are allocations, and so on and so on. The thing is, you can potentially shorten this process if, for example, you create an archive of these classes, you dump it on a specific location, and here I explicitly detailed those locations. And basically, next time when you start your JVM, because this archive it's there, um, it starts quicker, because the format how these classes are stored in this archive, it's slightly different. So it's not the same format as you store a file in a jar, for example. And because of this, basically just reading these dumped classes next time in the subsequent JVM runs, you can speed up basically your startup time. um, CDS basically, due to historical reasons, it was added since 1.5, so it's there since a while. Of course, by time there were new and new additions, so it got improved basically. At the moment, CDS contains only system classes. So basically, in CDS archive, you have only core library classes, like for example Java Lang, all these classes which are loaded by the Bootstrap class loader, not any other class. So only these classes in total, if you count them, there are more than 1,200 classes. Such classes are basically in this archive. Starting JDK 12, basically once you install the JDK distribution, it implicitly you will find implicitly this archive here. Of course, there are different paths, Linux and Winux, but this is not important. If you check this on your appropriate file system, you will see these archives. And of course, these are enabled by default unless you specify in most of the JDK distributions, unless you specify this Xshare off. In terms of improvement, just to give you an idea, maybe few hundred milliseconds. So I wouldn't say it's a very big improvement, but still it's an improvement, right? Because a few hundred milliseconds might mean a lot. Next one, it's called AppCDS. Basically, AppCDS, because you saw the previous one, it's a bit limited, right? So it contains only system classes. The AppCDS, it's there since in OpenJDK. It's since 10th version, and it extends the notion of CDS to basically application class loader and custom class loaders. And from this point onwards, it started to make a difference, because usually in our real life applications, of course, there are a lot of such classes loaded by the application class loader, but in particular also from or by custom class loaders. What is also important to mention in terms of content, because I told you these classes from this CDS archive, they are in a particular format. This format, in essence, takes 3.5 times it's larger than a normal jar file. And here I made for you an example. So I prepared such archive and I measured the number of preloaded or shared classes. So you can see for 4,000 classes, basically you create an archive of 22 megabytes, right? So it's a bit heavier. That's why also the recommendation it's actually to not go too much into extreme. I mean, put if you create these archives, AppCDS archives, create with only classes that you need. One more important aspect for this AppCDS, it's basically created. I also have some guidelines. After I present you some slides, we will go into the practice. This AppCDS, it's basically created in 3 steps, which sometimes might look a bit cumbersome. It's not really so straightforward. Just keep it in mind. So this, to conclude, is there in OpenJDK since the 10th version. Since JDK 13, this mechanism was basically enhanced, and it's called dynamic CDS. Why it's called dynamic CDS and static CDS? This is mainly due to historical reasons, but from a user perspective, dynamic CDS has a simplified creation procedure in the sense that, for example, if for AppCDS you need 3 steps, dynamic CDS for dynamic CDS you only need 2 steps. Basically, you start the JVM, you tell the JVM, please create this archive for me, and for the in the subsequent run, you basically use the previously created archive, and you can use it as is. One more important aspect, and this I think it's also interesting for you to get it. Dynamic CDS has a layered architecture in the sense that, for example, it's based on the base layer architecture, which implicitly this is based on the default archive, the one which is created when you install the JDK. And on top, the dynamic CDS archive contains only the additions, right? Not all the classes. In comparison to the AppCDS, AppCDS contains all the bundle. So this has a layering approach. And yeah, you can also go a bit extreme with this in the sense that, for example, you can add on top of this static archive multiple potential dynamic archives. So basically, let's suppose you have a different application. They share, for example, the same framework. You can create a static archive, and then on top you can create, for example, dynamic archives in particular for that kind of application. So you can play around with this. Nevertheless, HotSpot allows only 2 layers. So in HotSpot, you cannot go beyond these two layers. And maybe one more important point to mention, it's about the class path. Class path are very sensitive, especially for in both cases, AppCDS and dynamic CDS. But what is here in particular important to mention, if you, for example, try to launch a dynamic CD, to create a dynamic CDS archive, and that one it's based on the static archive, which was created with a specific path. If you don't have the same path in terms of dependencies, this process it's disabled. So there are some corner cases that you might face in practice. Nevertheless, it's good to be aware of this mechanism because you can benefit out of this dynamic CDS. And I will show you some real hands-on example how it looks like in practice. These are all the things that I briefly touched. So this is a history in HotSpot in regards to the releases, JDK releases, and what was there corresponding to each of them. So some important things I already mentioned, AppCDS in 10, for example, dynamic CDS starting 13. There is also so-called default CDS archive in 12. So all in all, after the CDS, dynamic CDS was there, of course, by time there were fixes, slightly improvements on this. All in all, to sum up, it's better to use the latest JDK if you want to really see some improvements. Otherwise, if you have, for example, if you are based on 11 LTS, you might not get quite a lot. For example, in my particular case, I really notice differences with 17. But of course, this is context dependent. Not all can use this. Nevertheless, keep this in mind. Here it's a bit in details. I won't focus too much on this slide because I anyway tweet the slides and they are public on my website, so you can download and read them afterwards. But if you are curious, the structure itself, how it looks like, basically, there are 7 regions that they are called like this. 3 of them belongs to the meta space, 4 of them belongs to the heap, and each such region contains, for example, different type of information, like for example intern strings, right? Maybe another point worth it is this archive starts as at a shared based address. It's fixed, basically. This address is this one in hexa. If you want to change this behavior, of course, there is a JVM flag. So if you want to say next time I create and start the CDS with a different address, you have to use explicitly to tell the JVM this flag. Or if you want to disable this, you can set 0, and in such a case, where the operating system basically just selects for you the address itself. Be careful why I'm mentioning this to you, because if you and in most of the operating systems, address space layout randomization, it's enabled by default. It might impact this rational in regards to the fixed address space. So basically, it might be impacted. That's why the best way to check this, it's actually when you start, for example, your JVM process, there is a flag. You can say just I want to log this, and you will find extra information. Not only this is a snapshot to give you an idea about the used regions in this case and the starting point address, but it also tell you if there are some problems while you use this and if it was mapped or not. Okay, so that's basically all in all it about this theory. Let's start with the practice, because the practice, I think, it's what you benefit most. For the practice, as mentioned, everything is public. So on GitHub, on my repository, basically, there is called Faster JVM Startup Technique Workspace. And here are all the steps I follow during this presentation, but not only, there is extra more, so you can take it offline and read it. Nevertheless, to have a smooth presentation, I'm just following the guidelines from here step by step. My demo, it's based on the Sprint Pad Cleaning application. It really doesn't matter. I took the Sprint Pad Cleaning because most of the people know it already, but you can take whatever application, because what I'm presenting to you at the moment has nothing to do. I won't change a line of code. I'm just playing with running the JVM and starting with the JVM with different flags. So it doesn't matter your application. It could be Spring based, it could be Quarkus, and so on and so on. And I'll focus on this dynamic CDS. First of all, just to make sure, so I have it already here opened and cloned. Just to make sure I don't mess up something, I'll select the 17 JVM, and then I'll just quickly package it by skipping the tests, because I want to be a bit faster today in the presentation. And then after this is basically built, the flag actually which tells the JVM to create this archive is especially this one. Archive classes as exit. And you give a name, and just like this. So I'm starting the Spring Pad Cleaning application with that one, and this is an important consideration, because usually the classes are lazily loaded. And this archive it's dumped at the end. So basically the CDS archive, the dynamic CDS archive is dumped at the end when you actually finish the JVM process. But it should be a normal. If you kill the JVM process, of course, the dynamic CDS archive is not created. It's better due to this rationale actually to browse a bit the application, hoping on the or relying on the fact that more classes will be loaded afterwards. So that's why basically now I'm trying to change, for example, some things in here, hoping that some of the classes will be actually afterwards loaded. So in the moment when I, for example, stop the JVM, I would have more classes loaded. I also can add a visit. So this is the famous pet clinic stuff. Nothing in particular. I also like to add the owner. So doesn't matter, the number and so on. And vegetarians, I can browse through this actually, error and so on. So let's suppose I started my application, I browse. In particular, I was trying to hit more functionality because I don't know what classes might be loaded lazily. And now I'm done. Yeah, you can ignore this exception. Spring is full of such. Basically, at the end, uh, it when you I just press Control C. Uh, by the way, not all classes, there are also some limitations with this. Not all classes are included in this archive. For example, if you have six classes due to the bytecode, it's a bit old. They are not included, and some of the classes you might see here they are not linked. This is due to the reason that in the moment that you stop the JVM, there is no enough information for this linking process. So basically, it will implicitly mean to load extra classes, which is not really allowed because you stop the JVM at that moment. So this overall works with some limitations. If you check, for example, your local system, you see here this archive DynamicCDS.jca was created. And basically, that's it. This was the creation part. If you get back, so we were actually here. If you now start the application, you have to specify this archive, and that's basically it. You specify this archive, and of course, as I told you before, you can also potentially profile this. I let you hear some comments, so you can do it on yourself to check this if it is really improved or not, and how was mapped and so on. But now what I will be focusing on, it's actually because I have this dynamic CDS created, I'll be focusing on comparing the startup times between the case when I really start the application without dynamic CDS and my case where I have this dynamic CDS. And let's see if there are some improvements. Before doing that, I would like to also mention, you see this message, starting pet cleaning application is. I don't really count on this. This is foolish. And the accurate way to really measure the startup time of the application, it's actually to query an endpoint from the moment when you start your JVM. This is a particular script I created. You have it also on the GitHub repository, and check from until the moment you get the first successful response. Why I'm not counting this? Because actually there are some aggressively lazy techniques that frameworks can choose, and it doesn't mean for me that if it's written here started play clinic application, my application is really ready to be used. So I'm going to do this. Basically, I'm going to create start two instances without CDS just by default. So what this does basically, it says I want to start on this port, I want to start with this class path, and listen, wait until the first request is successful on this port. So you can see it's a bit high load because I have usually if I don't have too many programs loaded, it's 7-8 seconds, but because I have also the browser and the Chrome tabs open, it takes more. I'm just trying to open a second one just to make sure the first time it's not really beyond the window. And let's see. So the first time was 16, the second one there was 14. Let's see now what I get if I enable, for example, CDS. To enable CDS, it's actually very simple. Yeah, as previously said, you just specify this, and all the other are basically for the port because I have already two JVM processes open. I'm using another port and my script basically which measures the time to respond. And let's see if it is lower than the previous timings or it is almost the same. So with 13, it's slightly better. Let's try another case. So it's not substantially better, I would say. Yeah, let's see with this one, the second run with DynamicCDS enabled. Yeah, so it's overall is 13 something, 14 something without, or 16 something without. All in all, there is a slight better speed up, but maybe it's not so, it's not a lot, I would say. And this is what I also noticed in my measurement. So here is the test that I did without Chrome tabs opened and so on. In on average, it's an improvement, but it's probably at least in my particular use case with this particular configuration, 1 second, roughly 1 second something. Now, if this is sufficient for you, you'll basically judge on yourself based on your use case. Nevertheless, this is the summary about this mechanism from HotSpot. So be careful, use the last JDK version. It's better actually. And also, if you, for example, try to create a dynamic CDS just by starting and stopping the application, you might miss some classes that will be potentially lazily loaded afterwards. There are a lot of constraints or a lot of points to make out of this. The first one, which is a bit contrary to what you know, is that if you, for example, create a jar, and if you run that jar with the if you run that jar after you upgrade the JDK version, it works. With CDS, it doesn't work. So with CDS, you need to keep the same JDK version. This is fixed in 19, but at the moment, the version you create the CDS archive with, you have to use it afterwards to run it. More important fact, also the jars, the timestamp. So if you, for example, regenerate the jars and you use this with the same path, but the jars have a different timestamp, it still doesn't work. So it's really strict in this sense, and also, of course, it's not class platform reusable. Of course, there are other restrictions, like, but this it's a bit hidden. If in the class path you have a jar which contains or refers other jars as a class path attribute, those jars are basically not included. Okay, so all in all, that's it. You can test it and play with it on your side, check if it fit or not. Next, I would like to tell you about a different JVM. It's called Eclipse OpenG9. It's actually it's a closer from a rational perspective to what we have in CDS, in the sense that the same shared, it's dumped on this basically after the application it started. And the important difference is here, this shared cache contains not only pre-processed classes metadata, it also contains compiled code. So this is the important difference between the hotspot and the OpenG9. And of course, because of that, you will see slightly better startup improvements. For the custom class loaders, this doesn't work implicitly. So if you have a custom class loader, sorry, you have to implicitly add support. I mean, for those classes loaded by that custom class loader. So there are two options to do that. And what is interesting about this SCC from OpenG9 is that you start the archive, you run it in the subsequent runs, and if one class is not part of the cache, it is simply dumped. So in comparison with the hotspot one, which is basically the archive that you create, it's there. So you cannot, the content, it's the same. In terms of structure, because also the J9 itself has a different representation of dealing with classes, you have ROM and RAM class. ROM it's basically a subset of the class containing pointers to interfaces, superclasses, inner classes, and so on. Only in the in the shared class cache, it's only the ROM class which is basically shared. All the other parts of the class, the RAM class, are in each JVM local memory. But this is one aspect. I think what is really important is that this contains also the compile code ahead of time. And that's why, for example, you will also notice now, because I'm doing this with Eclipse OpenG9, and you will see if there is a difference or not. So I'm switching back to my Git repository. And here I'm getting to the index, and in the index I have this one. And for this, I'm using the same repository. I'm trying actually to just change the JDK. So here I'm using S17. S17 means Semero Open G9. Okay, so this is enabled. As you can see here, it's OpenG9. This is optional, but I always do this. I repackage, and maybe while this is building, the option this time, because it's a different JVM implementation, so it has nothing to do with the hotspot, you have slightly different command line arguments. For example, this one is the most important. You specify the name of the cache, you specify the directory, and also I'm specifying some soft and hard limit for that. You can also use the quick start for this, and that's mainly it. So if I start, for example, with this first time, because the cache is not created, so here, as you see, the cache is not created. While I'm starting it, you will notice this file created already, and this is basically the SCC cache from OpenG9. Of course, it takes, especially first time, it takes a bit. Yeah, sorry, I forgot to kill all the running instances because I left some of them. So here I'm just, if I do JPS, nothing. Okay, I'm doing it again. Let's, yeah, maybe remove the cache. So I'm doing again, sorry, I forgot some JVM processing, the same port 8080 opened. So now it should start, and yes. So now if you get back in here, you can see this cache created. So first run is slightly longer, but I'm trying to actually do the same basically again, see if there were some quick improvements into that. And you see now the time is 6 seconds in comparison in the first one. But again, as mentioned, I really don't trust this because I have my own mechanism of testing. So which means basically I'm starting the application and I'm also setting a counter until I get the force 200 response from the server, which is this, in this case is the Spetling application. So it's starting. So you see 8 milliseconds, sorry, 8 seconds, which is basically almost quite a lot, right, in comparison with the previous cases. If I start it again, I expect to be more or less on the same. I mean, yeah, so 7.9. So as you can see, the improvement it's quite significant, right, in this case, in comparison with, for example, the default hotspot. So this is definitely something interesting, and in my opinion, these are my timings anyway. Today, because of the load, we got different timings, but still, I mean, the difference is quite relevant. The difference is quite relevant. What I also like about this, it's really highly customizable, and in my opinion, it's slightly easier to be used in comparison to, for example, the hotspot command line options. So it's up to you if you try this one, if you play with the hotspot. There are options, you just have to start on your own. The last point from this presentation, it's actually the ahead of time compilation. So if none of this fits your use case, and if you really need faster or raw starting time, startup times, I think you have to fully go to native compilation, which basically means using Graal VM native image, you take your application and then you compile it natively. So at the end, you'll have a native application. So you run it as a native application. The process, the overall process, how this is done, it's better explained in this paper. If you are interested in this, I advise you to read the paper in a nutshell. What happens during this? So you take your application, normally written. Then when you start to build with native, with Graal VM native image, there is an iterative approach where parts of the application are started and of course objects are allocated. There is a point to analysis, which basically analyzes all the reachable methods until it reaches a fixed point. The rationale is it's optimized only what is seen or what could be reached during the build time, because some other hidden parts, like for example if you use reflection and so on, these are not these are that the compiler itself doesn't know about this unless you explicitly tell him. So at the end, all in all, you'll get your executable. So once you run the executable, basically it will start, you'll see, quite fast. The demo itself, this time, I have switching back again to GitHub. You can check the third link. I also have one with Docker, but it's not for today. I leave it up to you. This time, basically, it's something to mention that I'm using the Spring native extensions. So you have to use Spring native extensions because otherwise there are a bit of limitations. So in order to show you this, I'm switching back to a different implementation. You will find it here. Basically, it's the same. It's Spring Pet cleaning, but it uses the Spring native extensions. I skipped the build time because this takes, at least on my machine, around 15 minutes to build it natively. And I will just quickly jump into showing you, for example, how this takes to start. So I'm using the pet cleaning with JPA. Let's make sure I don't have any process already running. And here, for example, if I start one, you see it's 300 milliseconds. If I start the second one, probably it will be more or less the same, right? If you want to see the Spring Boot logs, I'll create another one, and you see here this startup time 0 dot something. Yeah, so this is really, it's really fast, but you have to take into account uh, this it's not implicitly working. So if you take your project tomorrow, if you want to do it, you might end up with a lot of issues. The best way is to use already the framework, which provide the native extension. Also, in terms of dependencies, be careful because the dependencies outside of the framework and outside of the native extensions provided by the framework might also be challenging. And I experienced this on my own, so it might take a significant amount of time. But nevertheless, if you really want to start quickly, yeah, you have to to pay this cost. I mean, the preparation and the build and so on. Of course, because you go natively, there are some limitations. You have to specify additional configuration, for example, reflection, if you use it, dynamic class loading, not out of the box, things not yet supported, or things that might operate differently. For example, if you are using file recorder, right? This is not possible at all because this is like a process, a binary process started in a different way than how you started with the normal JVM. More about these limitations you find here. I think this is the best way to read about this because the Oracle Labs, the native image team actually keep this updated. But yeah, you have to be careful with this. All in all, I think that's it. I try to cover actually some important things in order for you to give a grasp what options are there, what timings are used, and you can judge on yourself what or which one you might try on your in your local project, what might fit or not. I think it's important to be aware such techniques exist, and if you need this in your project, yeah, why not go and test by yourself one or the other. Nobody can tell you ahead which might be, yeah, what might be better or not. References, there are quite a lot, but everything it's already public on my website. So I will also tweet after this session, so you will get all the resources I used today.